Oh, it's been a long day. Why is it so hot in here? I hate when he keeps doing this. What do you mean it's set to 73? Turn this thing down.
A few moments later.
I hate when he makes it so cold in here. Yeah, we gotta turn it up. This is driving me nuts. I have 2 roommates. Unfortunately, we all have our own preferences. I need something that's gonna keep me cool even when my roommate just keeps cranking the temperature up. I love a good old fan, but when I'm 3 hours into my differential equation study, I'm not thinking about turning a fan on. I need something that turns on for me when I want it to. Introducing the Smart Fan from Group 99. This product utilizes key skills gained from MEGN 200 to produce a state-of-the-art fan. With an easy-to-understand display and ergonomic interfaces, users have the ability to set a desired temperature that they want their fan to turn on at. Users simply press the left button to lower their desired temperature and the right button to raise their desired temperature. All the user has to do is focus on their work, and if the room temperature creeps past what they set it to, the fan will automatically turn on. Thank the Lord. Stop for a second. Did you see that? Yes, that's right. The fan actually has different speeds of rotation. If the difference between the ambient temperature of the room and the temperature that you set your fan at is greater than 3, 6, or 9 degrees Fahrenheit, the fan will actually rotate at higher rotational speeds. So instead of adjusting the fan for when it gets hotter and hotter in the room, the fan works for me. So your question might be, how did we accomplish all this? We're split into 3 main areas. This is the LCD component. It has a potentiometer here, which controls the backlight of the LCD, changing visibility for the user. As you can see here, we have the room. This is the ambient temperature room, which is read from the DHT11 on the top left up here, which comes through a port at the top of the container. The set is the desired temperature of the user. We use the left button to decrease our desired temperature, and we use the right button to increase our desired temperature. The other major area is this here. This is the DC motor. As you can see, we have an alternate power source hooked up to the DC motor to combat the amount of power pulled from the Arduino by the LCD. This alternate power source runs through the diode and a transistor, and then this is the PWM pin that controls our DC motor. These 2 wires back here are the ground and the power for the DC motor. They run up through the container all the way to the top where our fan is. As you can tell, there's a lot going on inside of our container. So it's a lot easier to break it down when I give you one of these. Let's work left to right. On the left, we have our Arduino R3. This is the center. This is like the brain of our fan. On the bottom, you'll see the 2 buttons. Each button controls one varying factor. One is the up temperature for the desired, and one is the down temperature for the desired. To the right of that, you will find the LCD. We were able to utilize skills we gained from worksheets and using the LCD previously to wire this LCD. And to the right of it, you can see the connection to the potentiometer, which we use to vary the background lighting of that LCD. Just above that, you'll see our DHT11. This has a wire that connects to a PWM pin or a digital pin on the Arduino board that feeds it the data, the ambient temperature of the room. It also gets power and is connected to the ground, completing the circuit. And then on top, to finish it all off, we have the entire DC motor circuit kind of isolated. We have our digital pin running into a 220 ohm resistor, which connects it to the transistor. The transistor breaks off into 2 parts. One part is the ground section for the alternate power source, and it also connects it to the ground of the overall circuit. The other side uses a diode, which connects the motor and the power from the alternate power source to power our fan.
Here I'm going to walk you guys through the flow diagram of our system while showing in full operation.
Currently, I am pressing the down button, which lowers our desired temperature. The second that temperature crosses the 0, the fan speed is 70, and increases to 150 when we cross the 3 threshold. We're going to now move to a difference of 6 or greater, which increases to 200. Now moving to 9, and this is the max speed at 255 PWM. We're now using the up button, which raises our desired temperature. When that ambient temperature is less than our desired temperature, the fan is off. To wrap this up, I'll show you when I set my house temperature to 75 degrees. As the house temperature raises, you can see the fan speed increase.